All right. So yeah, last time we talked about things like um, what is matter. We started with different type of matter, like quantifying matter, their properties, chemical or physical. Then we went on also to talk about how we can actually tell the quantity of matter, like the
Yes.
property, where it can be intrusive or extrusive property, and we did that. If I'm to ask, what is an intrusive properties of matter? Intrusive.
So
What is this?
I didn't get you.
Like what is intrusive? Like we had the extrusive and the intrusive properties
Oh,
of.
their physical properties and chemical properties.
Okay, now like how do what is this like intrusive property? Are you able to see there?
Oh yes, yes, yes.
Okay, what are these?
Those are the ones that do not depend on the amount of matter.
All right, it's just like it's more like the identity of that matter. Let's say the color. The color can be black, right? A black, yes,
Temperature,
yes, yes,
color.
yes, yes. It will be, it can be big or small, but you still call it black. You get? But some things like you say, no, 25
Mm.
kg. Kg has to differentiate like in terms of its kgs. So you say I have 2 kg, I have 5 kgs, right?
Yes.
Yes, so those are what we call. Then we went on to talk about two um, extrusive property as well. What were those?
Mm.
Yes, what were the extrusive
Those
prop?
are ones that depend on how much matter is available.
Example.
Or mass, the weight,
All right, then with that's good.
the mass.
Yeah, sure, sure. So and then the other thing that we did was we we talked about the prefixes, and of which you did in physics. I guess those negatives ones pay attention to, and I showed you how they are used, right? So we did all those. It's just a part of recording. You get me? Is that okay?
Yes,
Okay, since now we are doing what we call measurements,
yes,
we are doing what we call measurements.
yes.
Okay, all right. All right. So when we talk about measurements, we talk about like how we'll be expressing like. So when I'm talking there, like try to mute so that it doesn't disturb you the mic there. Eh? So when I ask you, then you open it, then you say something.
Yes.
Okay. So
Mm.
yeah. So we talked about measurements, of which I touched the part of prefixes. Then I couldn't go further. Why? Because you did in physics, like you explained. So let us
Yes.
look now at some basic measurements that we know. What we need to know is that um 10, all right, let me uh, 10, all right, 10 millimeter, all right, this is giving you this is equal to as 1 centimeter. Is that okay? Then 100 centimeter, this is equal to um,
Yes.
yes, 100 centimeter, this is equal to 1 meter. All right, and again 1000 meters, this is equal to 1 kilometer. Okay, is that clear?
Yes.
Sure. Then when you are
Yes.
when you are given 1000, suppose 1000 centimeter cubed, this is same as um, um This is same as, you can also write this one as 1 liter. All right, and the same 1 liter can be 1 decimeter. This is just same, right? Cubed. Is that okay?
Yes.
Sure. So those are the measurements associated with some chemicals that we'll be doing handling in the lab. Okay. And the other thing that we need to know is that when I say what is the same 1 liter, this 1 liter, it can be equal to 1000, okay, mils or milliliter. Okay, is that okay? Is that okay? Because
Yes.
the game which is here, take it at this point, the game which is there is that this milli we learned that is 10 to the power negative what, 3. You remember? So if I'm to bring this 10 to the power of
Yes.
negative 3 there, I substitute. Let's say I have 0 0 0 then times this 10 to the power negative 3 liters. Okay, so this is the use of prefixes. That one I've substituted where there was m, I've substituted with that factor there, and this is same as
Yes.
when you divide, that is same as we had 1000 there, then liters. This one is same as 1 over also 1000 down there, and then liters. You have seen? So this means that this and this will cancel, and we'll have just a liter. Okay, 1 liter.
Yes.
That's the reason why this 1000 milliliters is same as 1 liter, because that milli is still 1 over 1000. Is that okay? Or 10 to the power negative 3.
The screen has stopped showing.
Does
The
stop.
screen has stopped showing.
Okay, it will come maybe. Just try to.
The screen has stopped showing.
Okay, okay. It's now showing.
Yes.
Okay, it's showing, right?
Yes.
All right.
Yes.
Okay, so that is it. So that is about this, the use of prefixes, like to deduce those units. Then the other thing that we can talk about is the, let's say 1 mils. That 1 mil, like we have, like let's say 1 mil, right? I mean 1
It's
mils.
gone again.
It has gone.
It has gone again.
Okay, so what I'm going to do is let me just change the what's this, the, I take it to this one. Are you able to see? Are you able to see?
No.
Okay, let me do this. Let me just end this part. Even now it's not showing. Is it showing? Is it showing?
Oh, now it's showing.
It's showing now.
Yes.
Okay, okay, okay. All right.
Yes.
Okay, so now what I'm trying to say is, let's talk about something important now. Let's talk about density. Okay, density, it will be represented by the sleeping p like that. Okay, that's the symbol, so don't get confused. In physics you find this symbol. So density, we say it is given as mass over volume, right? All right, or sometimes you can see it is equal to mass over volume, like that. This d, you can use this d, but the one which is the actual authorized is the sleeping p, like that. So this is what you call a derived unit in physics. You looked at it, right? Because it's coming from two different quantities, right? Physical quantities. Yes, and the physical quantity. So this density can have units, kgs. Okay, when it is in kg of volume, make sure it is in meters cubed. Then when you have grams, make sure that your units, I mean your volume should be in centimeter cubed. This is what you need. Sure. So that is it. So if we are to demonstrate now, if I'm to tell you to say can you let me give an example now. A piece of platinum metal with a density of, let me just write that, with a density of 21.5 grams, okay, per centimeter cubed, has a volume of, so this is the volume, a volume of 4 point, you have a calculator there, right?
Yes.
Okay, has a volume of that. Okay, what is its mass?
Uh, mm. So the density will be uh,
What are we calculating?
the mass will be density times volume, which is 21.5 96.55.
Okay, this mass, because they was this
Yes.
from volume and also that you cancel, so remain in the grams, right? Right.
Yes. That's 96.535 grams.
Okay, so that is it. Like I'll just end there to the to one decimal point. Okay, so that is it. So that's how you can calculate the
Yes.
density. Yeah, that's just a practical. What if again I tell you to say, yeah, just get a calculator and analyze the data that you have. Suppose I tell you to say, the density of ethanol, a colorless liquid that is commonly known as grain alcohol, is 0 point, so this is the 0 0.9, I mean 0 0.79, 0 0.798. Okay, I want you to calculate as well, just for practice sake. Then
Yes.
muse liter, like that. Then
Yes.
calculate the mass of volume. Calculate the mass
Is that
given,
in grams or kilograms?
this is just grams. Then there is milliliter for the volume here. So
Is the density in kilograms or grams?
the density is in grams. This is just kg. This is 0 0.7
Milliliter.
milliliter. Yes, milliliters. There must be some conversion, I guess there. So it has
0.798.
0.7898. Yes, that's the density. Then they are saying calculate the mass given the volume 17.4.
Yes.
Okay, so what will be the, first of all we are calculating the mass.
Yes.
Yes, and we know that mass is equal to what? Density times volume, right? Okay.
Density times volume.
Yes, so if we were to put where there is density, we have
Yes.
0 0.78, I mean 0 0.798, then grams. Have you seen? I'll say per milliliter, like that. Then times, we have 17.4, okay? Then milliliter, like that. You have seen that the millimeters are going like that.
Yes.
Okay, so what's the answer?
Yes.
What's the answer?
Uh, mm, 13.88.
Okay, so we can
Point
round
eight
off,
nine.
yes, like just 13 point what 9, because of one decimal point. Like that's what we normally like we leave it with one decimal place, like that. So we just like 13.9, like that.
Yes.
Then grams. Aye. All right. So That's how you can calculate. Let us also try another one, like just for the sake of, and
Yes.
we forget the rest. So the other question says the density of sulfuric acid in a certain car battery is 1.41, okay, grams per milliliter. Then calculate the mass given volume. Calculate the mass of the volume 2242. All right, milliliter as well.
Yes.
What will be, we are calculating the mass. This is the density, this is the volume, so we're calculating the mass. What will be the mass? Punch there.
242.
Yeah, that is 242 volume. What are you getting? You are punching, right?
Yes.
Okay, tell me.
341.2 grams.
Okay, say 0.2,
Yes.
right? All right.
341.2 grams.
And the way we do, you can just, okay, 3.1 for just like this. So like we end here. This is this is how you can
Yes.
actually come up with this. Just be sensitive with units, chemist, right? Is that okay? Okay, so let's talk about now temperature. All right, so we are now going into details each and so, but for this one,
Yes.
it is like very important. Pay attention to what the formulas that we put for calculating different type of units temperature. All right, so what I'm trying to say is for temperature, um, let me just underline. Okay, which one is good, the black ink or the red one? Which one affects better there? The red one or the black?
I think the black.
The black? On
The red.
the red?
The red.
All right. So temperature, we know temperature, define it
Yes.
is just the degree of how a substance is actually what is temperature, if I'm to ask first before I even proceed? What is temperature? Just temperature.
Yes.
Okay, so when you talk about temperature is just a degree on how much the substance is cold or hot, eh? So it's just a degree. At what degree is it
Yes.
hot? At what degree is it cold? Aye? That's what we call temperature. So this temperature, it can be expressed in different units, but there is also a accepted units standard in that. Like I said, there are those for 7 fundamental quantities. You can measure them in different, like mass. You can measure in grams, but the standard is
Yes.
kg. Kg is that end. So the first type of units where we express temperature is what we call degrees Fahrenheit, or just Fahrenheit. All right, degree Fahrenheit. All right,
Yes.
all right.
The direct quantity. Okay.
I don't know if you were able to see, but this one will be denoted by letter F to mean degrees Fahrenheit. Fahrenheit. All right. So that's the first way of presenting the
It's okay.
units. Okay, the units for what's this, for temperature. The other one, which is common known, is degrees,
Yes.
which is degrees Celsius. So be also able to express temperature in these measurement units. So all right, So what we need to know is that
Yes.
there's also the other one where we express, which is the standard, is what we call Kelvin. All right.
Yes.
Okay. So
Kelvin.
sure. So what we do is we'll say, let me start with the same Kelvin. On the temperature scale, on the Kelvin scale, all right? So if I have temperature in Kelvin, and I mean I want to calculate temperature in Kelvin, and I'm given temperature in Celsius, so I'll add this plus 273, all right? 273.15. Is that okay?
Yes.
This is how we get temperature in kelvins. So this means that on a Kelvin scale, 0 degrees is equals to this one we have here, 273.5. Always please, I remember at secondary we could only do 273, but this time around is 270.
Kelvin.
Yes,
Yes.
273 1.5. This one 0.15. Always don't forget the 0.15. Is that okay? Is that okay? So if I'm to calculate temperature now,
Yes.
yes, suppose now I have a temperature, I want temperature in degrees and I'm given temperature in Fahrenheit. So the formula that I'm going to use is that, first of all, we have established this relationship. I don't know, there are people talking in the background. Yeah, you can just pause a bit. There are people talking there. Okay, first we have established this relationship because the goal is we just want to find, like, listen, like the goal is we want to find the ways and means of actually like moving from one place to another, just like that, moving from this to this, again moving to from this to this. This is what we want. Now let us establish some relationships. So the first relationship made is this one: Kelvin is equals to Celsius plus 273. We have made that one, right? So the other one, suppose you are given temperature in Celsius, okay? I mean you are given temperature in Fahrenheit, then you want to calculate it in, I mean you want to take it in Celsius like that, okay? Then you have temperature in we have temperature in Fahrenheit. So what we are going to do is we'll say 5 over 9, open bracket like that, then that temperature in Fahrenheit, all right, then minus 32. Is that okay? All right, let me know if you are getting me on this one before I move to the next segment. Are we there?
Yes. Let me just finish writing this part.
Oh, you're writing something, okay.
Okay.
All right, so that is it. That is it.
I'm done.
All right. So the other way is we have temperature in suppose we have temperature in Celsius, then we want to, I mean we have temperature in Celsius, we want to take it in Fahrenheit. So the other relationship let us establish as well. So this is the second relationship. We have the third relationship there. So what we are going to say is that we need to have temperature in Celsius, okay? So we have temperature in Celsius multiplying with, let me write this, let me write it like this. So we need to write now here the inverse changes. This 9 comes on top for Fahrenheit, then we have 5 there, then open, we bring that Celsius we have, all right, then we add. Now it's more like they are changing here, it's now becoming plus 32, then here there was the inverse and we have substituted this. This is the relationship. If you can master very well, you need to come up with a way on how you can master this, otherwise it's very important, like the Fahrenheit and the Celsius. Is that okay? So under this we have seen that this positive has changed to, I mean this negative has changed to positive, and also
Yes.
yes, so you have to find the unique way of mastering it. Let me give you a minute to look at it.
Yes.
All right, so now having these relationships, let us try some examples. Like I've gotten questions from one of tutorial sheets. Okay, so the first question, all right, so the first question states, I'll be just giving data, then you'll be able to see how it will be coming, eh? Is that okay? Getting me? Emma?
Yes, I can get you.
Alright, so the first question says, soda is an alloy of tin and lead whose melting point is 22 to 224 Celsius, like that, degrees. Then what is the melting point in Fahrenheit? Okay, this is the first question. The other question says, um
22.4 degrees.
no, it's just 224 224 degrees. Okay, is that okay?
224.
Yes, 224 degrees. Find F Fahrenheit in short.
Okay.
Okay.
Yes. Then what's the rest of the question?
Okay, the other question is, helium has the lowest boiling point of all the elements at negative 4 5 2 Fahrenheit. Then convert this temperature to degrees. So in short, 5 degrees, like that. That's how I can simplify the question.
Scientific.
Then question C, it says mercury, the only liquid metal at room temperature, this is true, melts at negative 3.8 Celsius degrees there. Convert this temperature in Kelvin.
Yes.
So in short, find Kelvin. All right, let me check something there. All right, okay, there's a hand. Okay, in short, yeah, I was thinking of that sound. So
Yes.
So yeah, so I don't know what I'll do. I don't know, like if you are still active there such that I can proceed to other parts, or I leave a homework, I bring other questions.
Yes, I think that will work.
yeah, so let me just type questions. In fact, I would have typed in this document so that this document becomes at 30 minutes, so that, because I mean the video, I'll send the video as well. Right now, like after this, I'll publish it and I'll send it. So I think what we'll do is, let me just send work, like I'll type work.
Okay.
Yes, I'll send work. Okay, in fact, let me just put the same work in this document.
Okay.
In this video, let me just put the same work.
Yes.
Let me put this work in just a moment. Just a moment, don't leave, because this is where it's quite sensitive, so I need at least All right. Okay. Let me just do that. Okay. Let me just put those questions I'm talking about so that you find them in the document. All right.
Alright.
Just a moment.